Good morning. Okay, like usual, I did all the work beforehand just because the Porto has issues, but I'll walk you through what I did and explain what I did. So this is week 11's assignment. I went ahead and entered my data into SPSS. And then from here, I had already pre-wrote all my stuff. So I'll start at the beginning. My question is, what is the correlation between the number of beds in a hospital and the number of full-time employees, full-time physicians employed at that hospital? My hypothesis is for the null, there is no correlation. For the alternative, there is a correlation. The first thing I want to do is do the scatter plot. So you go to graph, down to legacies, down to scatter dot. You choose the simple scatter, define. In this case, my Y is full-time physicians employed. My X is the number of beds. And then I hit OK. And as you can see, I've already transferred it over. So as you can see, there appears to be a somewhat positive correlation. As I said, there appears to be a moderate positive correlation between the number of beds and the number of full-time physicians. There is quite a few outliers on the scatter plot. Next, I'm going to run my descriptive statistics. So analyze, descriptive statistics, explore. You put both of them into the dependence list, the number of full-time employees and then the number of beds. You want to run your test for normalcy and your histograms. Everything else is fine, so I'm not going to go over that. As you can see, we have no missing information. It looks like the average number of full-time employees is 118, and the average number of beds is 482. It looks like it is normal data. I also went ahead and calculated to make sure our information was below the 1.96. So I divided the skewness by the standard error. So in this case, it was negative 4.5 divided by, negative 0.405 divided by 0.524, which gave us negative 0.7729, which is below the negative 1.96. So our information was normal. You can see our information, the histograms, the plots, my box plot, which appeared to have no outliers, the histogram for the beds, plots. Okay, now we're going to run our correlation tests. So I go to analyze, correlate by variant. Okay, so I want to make sure both my variants are in the variable. I want to make sure I'm running the Pearson's, Pearson, the two-tailed and the significant correlation. We didn't mess with any of the other stuff, so we're fine with there. I'm going to go ahead and hit OK. As you can see, it has calculated our R value. So sorry. My R value is 0.588, which, according to the scale we follow, is a moderate to strong correlation. But given the p-value is statistically significant, it is leaning more towards strong. Scroll down. And I said that because of the R value, therefore the information is moderate. It is a moderate relationship between the number of beds and the number of full-time employees. The significance level is statistically significant at the alpha 0.05. Once again, it is a moderate to strong positive relationship between the two variables. And because of the significance level, it becomes statistically significant relationship between the two variables. Our coefficient of determinant determination I calculated, and it gave us a 34% variance. Once again, I'm so sorry for yawning. So my conclusion, a bivariate parsing correlation test was conducted to examine the relationship between the number of beds and the number of full-time employed physicians in the hospital. There is a moderate to strong relationship between the number of beds in the hospital and the number of full-time employees, physicians specifically. The R value was 0.588. The N was 19 and the P value was 0.008. The results indicated that the relationship is not only moderate to strongly positive between the two variables, but also statistically significant at the alpha level 5. Therefore, we reject the null hypothesis. Thank you very much. Have a wonderful day.